So our question is, what is the difference between quantitative and categorical data? Give an example of each. So the first thing we need to know is what's the difference between the two. So I'm going to start off with quantitative. And when you're looking at quantitative data, we're looking at numbers that you can measure or numbers that you can find an average of. So I'm going to say numbers that you can find the average of. Okay, so when I say that, I'm talking things like test scores would be an example. So test scores, if you take the average of 3 students' test scores and you average them, you would get an average test score, and that average test score actually means something. If you talk about the height of somebody, that would be another example of quantitative data. So if you took the height of 10 different people and you found the average of their heights, those are all heights are things that you can be measured, that you could measure, and you can also take the height, take the average of that group, and that average height would still mean something. Okay, so categorical data, let me write this down. So categorical data is like a classification or a number that's specific to one thing. It can't be measured. So what I mean by classification is it's something that defines something. So like favorite color would be an example of categorical. So your favorite color would be red, blue, green, black, yellow, white, orange, whatever color it is. Those would all be examples of categorical data. Hair color, occupation, those are all categorical data. But using numbers, numbers can be categorical also. So what I mean by that is something like zip code. You don't measure your zip code or your phone number. You don't measure your phone number. So how I was talking about earlier about taking the average of something, like you could take the average test score and that means something. If I take two people, let's just do two people's phone numbers and I average their phone numbers, that new phone number has no meaning, okay? So that would be an example of categorical. It's just something that helps categorize. It's just an identifying piece of information. Next question, describe the mean, median, and mode using less than, greater than, and equal signs. So we have a set of data, 5 different numbers, 68, 61, 71, 70, and 61. So we need to find mean, median, and mode. So for mean is your average. The mean, what you're going to do is you're going to take the 5 numbers, add them up, and divide by the number that you have. Okay, so you're going to take the sum of all numbers and divide that by the quantity of numbers. Okay, so how many numbers do you actually have? Okay, if you're going to use your calculator, make sure you put that all in parentheses. So what I would do is, I'm not going to rewrite this, I'm just going to go ahead and write right on this example. So for my mean, I would take these 5 numbers, add them all up, put it in my calculator, and then divide by 1, 2, 3, 4, 5, because I have 5 numbers. So when you do your mean, you have to add those top numbers together first when you're putting it on your calculator, otherwise it will not come out correctly. So this comes back as 331 on top. Divide that by 5, and that means my mean is 66.2. All right, so median and mode for both of those, well, mode you could do ahead of time right now. So mode means the most occurring. So the number that happens the most in your list. So the most occurring number is your mode. So I have 68, 61, 71, 70, and 61. And if you notice, the number 61 happens 2 times. And that everything else only happens once. So your mode is 61. Just as a heads up, I'm making these numbers up right now, but let's say I had 3, 5, 7, 9, 3, and 5. Notice that 3 happens twice and 5 happens twice. If that happens for your mode, you would list both of them. You would say that both 3 and 5 are the most occurring numbers in your list. Okay, so that's a made up example, totally different numbers. But just so you know, if that happens, most occurring, you would just list it twice. All right, so we have our mode is 61. We have our mean, which is 66.2. The last thing you need is your median. Your median is your middle number. But when we say middle, you have to have them in order first. So the first thing I need to do is write this list in order. So I have a 61, 61, we're going least to greatest, 68, 70, and 71. So you put them in order. And then right now I have 1, 2, 3, 4, 5 numbers. So the middle number right here, so I have 2 on the left, 2 on the right, and I have 1 in the middle. That means that my median is 68. So I have 3 numbers. I have 61, which is the smallest number in my list. I have 66.2, which is the mean, the middle number, and 68 is the largest. So notice I wrote them smallest, middle, largest. And now what I'm going to do is I'm just going to label them. So 61 was the mode, which means the mode is the smallest number. That's smaller than, less than. 66.2, which was my mean, which is less than my median. So all you have to do is put them in order from least to greatest and then name them. So my answer would be mode is less than mean, which is less than your median. Okay. Also as a side note, when you're doing median, again, if I had some made up numbers, 3, 5, 6, 7, 8, 9. When I look at my middle numbers here, notice that the middle number happens somewhere in between these two. So I'd have 3 on the left, 3 on the right, and something in the middle. I only have 6 numbers. So what you're going to do is you're going to average these two numbers. My median would be 6.5 if I have an even number of numbers. So if I had 6, the average would be the middle two would be your median. Okay, so 6.5 would be my median. Again, those are made up numbers just in case that were to happen to you. Find the mean for the data below. Round your answers to the nearest integer. So first thing you need to know is, what is this? This is a frequency table. And a frequency table basically is just a table that tells you how often something happens. So I'm not going to write all of this out, but basically what it's saying is how many pets are owned, 0, 1, 2, 4, or 7. So there was a sample taken, and 9 people, because that's your frequency, 9 people said they have 0 pets. So what that means is when you took your survey and you asked everyone, you had 9 different people, 1, 2, 3, 4, 5, 6, 7, 8, 9. You had 9 people answer 0. 8 different people answered 1. 1, 2, 3, 4, 5, 6, 7, 8. 2 pets, there were 3 people. 4 pets was answered twice, 2 times. So you're just writing it twice. 7 pets happened once. So basically all that is a way to condense down a list of numbers. So frequency, if I add all of these numbers up, is how many pieces of data are actually inside my list. So if I add up 9, 8, 3, 2, and 1, I should have 23 pieces of data inside my list. So if you were to count all these, count them all out, you should get 23. So there's 9 here and 1, so that's 10, 18, 19, 20, 23. So you have 23 pieces of data. All right, so now you're finding the mean. So you have a couple options. You could just add all of those up and divide by 23. Take the sum and divide by 23. And that will give you your mean, because there's 23 numbers, add them all up. And you do have to count 0. Okay, so 0 counts as an answer. So you can add 0 plus 0 plus 0 plus 0 and keep going. And then 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 4, 4, and 7. But that gets a little bit messy. So what you could do, instead of writing that all out and adding them all up, what you could do is just kind of multiply these two rows together. So 0 happened 9 times. 1 happened 8 times. 2 happened 3 times. 4 happened twice. And 7 happened once. Why does it work that way? Why can I multiply those together? Because if I multiply this together, that means 0 came back here, 8, 6, 8, and 7. So if I go over to the side here, notice all of these numbers right here add up to 0. All of these numbers right here add up to 8 because there's 8 ones. 2, 4, 6. Right here you have 6. That's the number that was here. 4 plus 4 is 8. So all I'm doing is I'm just kind of simplifying it so I don't have to write that list out every time. I wrote the list out in this video so that you can understand what's happening, but really what you could do is just multiply them together and then divide by the frequency. So add those all up, divide by the frequency. Again, make sure you add the top row together first. So I got 29 when I add all that top stuff up, and then divide by 23. So if I divide by 23, I get that my answer is 1.26. It asks you to round to the nearest integer. So the nearest whole number, I would round down on this one. I would get 1 as my answer. So in this question, we are given a list of data, and the question asks us to use a calculator to find the mean and standard deviation of the data and round to the nearest tenth, which is the nearest 1 decimal place. So we are going to go ahead and use Desmos to do this problem. You can also use your other calculator. Okay, so what you're going to do is you're going to go to desmos.com, type in and click on Graphing Calculator. And then when your graphing calculator pops up down at the bottom, this little tray, you're going to show your keypad. You're going to go over to Functions. And then across the top, you have your different menus. You want to click on Stats. And since we are looking for the mean and the standard deviation, the first one we're going to do is mean. It's going to pop up here. You're going to just type in your list of numbers and hit Enter. And I get that my mean is 644.9 if I round to the nearest tenth. For standard deviation, you're going to do the exact same thing. So I'm going to start a new line right here. I'm going to click on Functions, Stats menu, Standard Deviation, and then type in my list of numbers one more time. Hit Enter, and I get that my standard deviation is 163.0. All right, we have Jerry keeps track of the number of minutes he spends exercising over a several week period of time. Within how many standard deviations from the mean do the values fall? We're given a list of data, and we are going to go ahead and draw out our normal curve, and we need to label our normal curve as well. So drawing my normal curve. In the middle, I have my mean, so I need to find my mean, and then on each side, we have 3 standard deviations that we are going to label. So first thing you need to do is you need to take your list of data and you need to go put it into Desmos. So if you need to pause for a minute and go put that in your graphing calculator, or go to desmos.com and put in your data and find your mean and standard deviation. If you need help, go back to the question previous and it shows you how to plug it into Desmos. All right, so if you did that correctly, when you plug it in and use a graphing calculator, you should have gotten your mean was 66 and your standard deviation was 22.5. So on this one, you should be using a graphing calculator or Desmos to find the mean and the standard deviation. So once I have my mean as 66, you're going to label that right in the center of your normal curve for your mean. And then you're going to add your standard deviation over to the right. So you're going to take your 66 and add 22.5, which gives me 88.5. 111 plus 22.5 would give me 133.5. And then going the other direction, so this is 1, 2, and 3 standard deviations away from the mean. And then below the mean, same thing. We're going to go 3 standard deviations out to the left. So 66 minus 22.5. I'm now at 43.5. Subtract it again, you get 21. Subtract it one more time, you get negative 1.5. So the question is asking you, within how many standard deviations from the mean do all of the values fall? So 1 standard deviation from the mean would be from 43.5 to 88.5. So 1 standard deviation from the mean means go out in both directions, 1 standard deviation. 2 standard deviations out from the mean in both directions would be from 21 to 111, and then 3 standard deviations out from the mean would be from negative 1.5 to 133.5. So what we want to do is we want to look at our values in our list of where they fall. So basically what I would be doing is saying 63 falls somewhere in between 43.5. So 63 is in here. 35 is somewhere between 21 and 43.5. 46 is somewhere between these two. Now you don't really have to graph all of them. Basically what I care about is where is the lowest value and the highest value. So the lowest value is 35, which I already plotted. So 35 is here. And then the largest value I have is 105, which is here. So the question asks, all of my data then falls somewhere between those 2 points. So if I were to graph all these extra points, it would be somewhere between the 35 and the 105. So the question is asking, if I were to go through and look at 1 standard deviation from the mean, 1 standard deviation from here to here, do all of your values fall within 1 standard deviation? And the answer is no. If you look at 2 standard deviations from the mean, that would go from here all the way across to here. Does that capture every single one of your data values? And the answer is yes. So by the time you highlight 2 standard deviations from the mean, we now get all of the points from your list included into our answer. So our answer here would be 2 standard deviations. A study of football players found that they have a mean weight of 220 pounds with a standard deviation of 13 pounds. What percent of football players have a weight below 200 pounds? So in order to do this, we have to find our z-score. So as a reminder, a z-score just means how many standard deviations above or below the mean are you? And that formula is given to you on our formula sheet. So I kind of snipped the picture out here, but it's inside our notebook, and you will be given the formula sheet on your final exam. So the z-score formula, you take your value and subtract the mean and divide it by your standard deviation. So I was given that the mean is 220. I was given that the standard deviation is 13. So to find my z-score, you take your x value, and the x value is what are they asking us to find. So they're asking us to find 200 minus the mean, which is 220, and divide that by your standard deviation, which is 13. And then as a reminder, when you do these problems, you want to make sure that you put the top in parentheses if you're going to use a graphing calculator or a calculator at all. And you would get negative 20 divided by 13, which gives you a z-score of negative 1.54. Now what that z-score means is on your normal curve, if you have your mean centered at the middle, this would be 0, and you have 3 standard deviations, 3 standard deviations below the mean and 3 standard deviations above the mean. All this z-score means is at negative 1.54 is at negative 1.5 basically, standard deviations below the mean right here is where that number is sitting. So that number 200 on our normal curve is sitting at about negative 1.5 standard deviations below the mean. Now the question says at what percent of football players have a weight below 200 pounds. So below 200 pounds means I'm looking for this area of the curve underneath to the left because it's below 200 pounds. So what I'm going to do is I'm going to take this z-score of negative 1.54 and I'm just going to look it up in my z-score table. On your z-score table, it always gives you the area or the probability underneath the curve is always the shaded part to the left, and that's what I'm looking for. So whatever I look up as my answer will work for me. So in this problem, what percentage of this curve is shaded? I am going to look up negative 1.54. So you have positive and you have negative values on your z-score table. So I'm going to scroll through to the negative values. Notice there's a gap here because I couldn't fit the whole page on the slide. But you would keep going down until you get to the first two decimals, which is negative 1.5, which is right here. So I'm going to be pulling my answer out of this row of numbers. And then the second decimal place is a 4. So across the top, I'm going to find where the 4 is, and I'm going to look at this column. So you're going to go to the point where you see your row and your column have intersected, and that is 0.0618, which if I change that to a decimal is 6.18%. So move your decimal point 2 points to the right. So 6.18% would be my answer. Just as a heads up, that is anything to the left of or less than 220 because I shaded it to the left. As a reminder, this whole curve adds up to 100%. So if I were to ask you what's greater than that 200 pounds, that would be everything shaded to the right. That would be the remainder part of my graph. So that just means if I were to shade to the right, and the question doesn't ask this, but if it were to pop up, if I wanted the area to the right, in order to do that, I would have to do 100% minus the 6% that was on the left, and that means that 93.82% is everything greater than. The question asks for less than, so our answer is just 6.18%. The average grade on the Unit 1 assessment was a 78 with a standard deviation of 4.1. Where do we expect the middle 95% of the distribution to fall? So I'm going to draw myself a middle curve, a normal curve. In the middle of that, I am going to put my mean. And your mean in this problem was given to you at 78. 3 standard deviations on both sides. Sorry, I know that's not the best drawing. Add and subtract your standard deviation of 4.1. So if I add 4.1, I get 82.1. Add it again, I get 86.2. Add it again, I get 90.3. Over on the left, I get 73.9 if I subtract it, 69.8, and 65.7. So then you need to remember the empirical rule. The empirical rule says 1 standard deviation out in both directions includes 68% of our data. 2 standard deviations out in both directions is 95% of our data. And 3 standard deviations out from the mean in both directions is 99.7%. And we know that you need 100% underneath the curve completely, so that extra 0.3 is outside in those tiny little tails. So this question asks, where do you expect the middle 95% to fall? So the middle 95% would be from 2 standard deviations out in both directions. So the middle 95%, we're just looking for the interval, would be 2 standard deviations away. So depending on what the question is asking, it's 2 standard deviations. If it asks you for the actual interval, you would say it's from 69.8 to 86.2. A grocery store will only accept apples that are at least 3.45 inches in diameter. Be careful with the wording of that, at least. At least 3.45 means I want 3.45 or more. An orchard has a crop of apples that are normally distributed with a mean diameter of 2.75 inches and a standard deviation of 0.35 inches. What percent of the apples will be accepted by the grocery store? All right, so we have a mean of 2.75 and we have a standard deviation of 0.35. 2.35. So the very first thing I'm going to do is I'm going to draw my normal curve, label everything, so my mean in the center is 2.75, 3 standard deviations on both sides, adding and subtracting to get your numbers. So 2.75, if I add that 0.35, I'm going to be at 3.1, 3.45, and 3.8. If I subtract 0.35 from both of those, I get 2.4, 2.05, and 1.7. So make sure you understand where those numbers come from. I'm just adding and subtracting my standard deviation in both directions. Now the question asks what percentage of the apples will be accepted by the grocery store. So I have to go back up, and it says that it accepts apples that are at least 3.5. So again, remember, at least 3.45. If I told you like to bring at least $5 with you, or going on a field trip, bring at least $5 with you. At least $5 means you need to bring minimum $5 or bring more with you. So at least 3.45 means I want to find everything bigger than 3.45. Now the good thing about this problem is if you look at your graph, 3.45 is right on one of our intervals on our lines for our standard deviation, which means we don't need to do a z-score. A z-score is used anytime the data value falls between standard deviation. So for example, if I got 2.6 right now, if I want to do 2.6, I would have to use a z-score and look it up on my table. But since I have 3.45, that is right on my line, I can use the empirical rule, which remember is the 68%, which means both of these are 34%. And then 95, if I finish out both of those, we know these ended up being 13.5%. The next ones out were 2.35%. And if you label all of these correctly, it should add up to 100%. And the outside is 0.15. So those we kind of memorized. You can figure them out by saying, okay, this is 68%, split it in half. This is 95%. So if I subtract 95, take out the 68%, that leaves me with 27% left over. Half of it goes into those two. And then do the same thing for 99.7 and so on, and find each piece. Otherwise, this is kind of a memorization part. You want values that are greater than 2.35. So greater than 2.35 means I'm sorry, not greater than 2.35, greater than 3.45, which means I want all of this area over here. Okay, so basically all I need to do is I need to look at each section that I have given to me in my graph. So I have 2.35% and I have 0.15% out in the rest of that little tail. So those two sections of my graph make up a total of 2.5% of the data, and that would be our answer. A set of data has a mean of 67 and a standard deviation of 6. Find the z-score of the value of 59. So we did an example like this earlier, so I'm going to do this one pretty quick. Your x value is 59. We were given our mean of 67, a standard deviation of 6. If I look at my formula sheet, there is a formula that says I take the value of x, I subtract my mean, and I divide by the standard deviation. So this is a straight plug in your numbers. I just wrote that backwards. Plug in your numbers for your value. I was writing it backwards there. Make sure you take the x value, which is 59, and subtract that from your mean, which is 67, and then divide by 6. Again, always put the top in parentheses in your calculator first, and then get your answer. So if you do 59 minus 67, we get -8. -8 divided by 6 in my calculator will give me a -1.33. That is what my z-score is. If I asked for a percentage, you would look that number up on your z-score table.